All right, let's tackle a question that trips up pretty much everyone at some point in math class. Why on earth is pi equal to 180 degrees? How can a number be an angle? Let's dive in and make it all make sense.
So you first meet pi, and it's this number, right? 3.14 something something. Then it starts showing up in all these formulas for circles. And then out of nowhere, a teacher says that pi equals 180 degrees. What? How can it be all of these things at once? It feels like pi is having a total identity crisis.
But here's the thing, it's not as crazy as it sounds. These ideas aren't disconnected at all. They're actually part of one big, elegant story. So what we're going to do is just slow down and build that story from the ground up, step by step. You'll see how it all clicks together perfectly.
And our story, as you probably guessed, starts with circles. The whole secret to understanding pi is hiding in one simple fact that is true for every single circle in the universe.
I want you to just picture any two circles. One could be the size of a coin, the other the size of a planet. But here's the deal, they have the exact same shape. One is just a zoomed in or scaled up version of the other. You can't squish a circle and turn it into an oval, right? You can only make it bigger or smaller. And in geometry, we have a word for that. We say all circles are similar.
Now, why does that matter? Well, this is the really cool part. Because they're all just scaled copies. If you measure the distance all the way around the circle, that's the circumference, and then you divide it by the distance straight across the middle, the diameter, you get the exact same number. Every single time. It doesn't matter if it's a tiny little circle or a massive one, that ratio is always constant.
And you know, when you find a number in nature that just always shows up like that, you've got to give it a special name. And that's exactly what mathematicians did. They called this universal constant pi. So at its absolute core, that's what pi is. It's the number you get when you divide a circle's circumference by its diameter.
This is such a big deal. Pi wasn't just some number someone made up. For thousands of years, people, builders, astronomers, engineers, they all noticed this incredibly stable pattern. They saw that the distance around any circle was always just a little bit more than 3 times the distance across. Math didn't invent this pattern, it just gave it a name.
You can even see it in the history here. The idea of pi has been around forever. Ancient civilizations, they knew about this fundamental relationship. Then you get brilliant folks like Archimedes who figured out super clever ways to get a really good estimate. That famous symbol we all use today, pi, well, that came way, way later. The concept is ancient.
Okay, so we've established what pi is at its heart. It's this constant ratio. But how in the world do we get from a ratio to an angle? Well, to build that bridge, mathematicians have this awesome tool that makes everything super simple. It's called the unit circle. Now, don't let the name scare you. A unit circle is simply a circle where the radius, that distance from the center to the edge, is exactly 1. That's it. Its real power is just how simple it is. When you set the radius to 1, a whole bunch of complicated math suddenly becomes crystal clear. This number, 1, it's like our magic key for this whole thing. By locking in the radius at this simple value, we get to see what pi is really doing, all by itself. So you probably remember the formula for circumference, right? C equals 2 times pi times r. Okay, now watch this. This is where the magic happens. We're using our unit circle. So what's our radius? R, it's 1. So we plug that in. C equals 2 times pi times 1, which is just 2 pi. It's that simple. The entire distance around our special unit circle has a length of exactly 2 pi. Okay, now think about that for a second. If going all the way around is a distance of 2 pi, what about just going halfway around? Well, yeah, it's just half of that distance. And what's half of 2 pi? It's just pi. So on our unit circle, the length of that half-circle arc is exactly pi. Now hang on to that thought. That is super important. So notice what we just did. We connected pi to a length on our special circle. The next piece of the puzzle is to connect that length to an angle. And to do that, we need to talk about a different way to measure angles, called radians. You know, the word radian sounds a lot like radius, right? That is 100% on purpose. Here's how it works. Imagine you have a piece of string that's the exact same length as the circle's radius. Now take that string and lay it along the edge of the circle. The angle that gets formed from the center out to the ends of that string, that's exactly 1 radian. See? It's a way of measuring an angle using the circle's own ruler. It's radius. And now, this is where the unit circle just shines. Remember, what's its radius? It's 1. So on our unit circle, an angle of 1 radian carves out an arc that's 1 unit long. This is the big aha moment. On the unit circle, the number for the angle in radians is exactly the same as the number for the length of the arc. This is the key that unlocks the whole puzzle.
Okay, let's put the pieces together. We know 2 things now. 1, a half turn on our unit circle has an arc length of pi. And 2, on that same circle, the arc length is the same number as the angle in radians. So, you see where this is going, right? The best way to think about degrees and radians is like thinking about inches and centimeters, or Fahrenheit and Celsius. They're just 2 different systems, 2 different units for measuring the exact same thing. And in this case, that thing is an amount of turning or rotation.
Let's make this super clear with this table. A full turn, a complete circle, we all know that's 360 degrees. Well, we just proved the distance around our unit circle is 2 pi. So a full turn is also 2 pi radians. Same turn, different name. Now let's look at the half turn. We call that 180 degrees. But what did we figure out the arc length for a half turn was? It was pi, which means a half turn is also pi radians.
And there it is. That's the answer. That's why we say pi equals 180 degrees. It's because they are literally just 2 different names for the exact same amount of rotation, a half turn. One name, 180 degrees, comes from an ancient human decision to slice a circle into 360 little pieces. The other name, pi radians, comes directly from the very nature of the circle itself.
So let's just quickly run through those common points of confusion one more time. Is pi just 3.14? Nope, that's just the first few digits. Pi is an exact number that goes on forever. Why do we call a straight line angle pi? Because a straight line is a half turn, and a half turn is exactly pi radians. Are degrees and radians totally different things? Not at all. They're just different units, like feet and meters. And why bother with radians? Well, for higher level math, they just make more sense because they're built right into the geometry of the circle.
So here's the big idea to take away from all this. The next time you see that symbol, pi, remember it has this cool double life. On one hand, it's a fundamental constant of the universe, the ratio of circumference to diameter for any circle. And on the other hand, it's the most natural way to describe a half turn in the language of circles. A constant, a length, and an angle, all connected by one beautiful idea.